Okay, part 2 of Unit 1, Lesson 2 on parabolas. We start off with something here for you to fill out. So I'm going to give you a moment, pause the video here, and copy this part so we can talk about it and walk us through what we're going to do for the next 4 problems. Okay, so hopefully you paused the video, you wrote down these 6 things to fill in, and let's talk about it. So these are actually the equations for your different types of parabolas. So we have our classic up and down orientation parabolas, and we're going to use this formula to represent that. And we have our sideways left and right parabolas that we haven't seen, they're new, and it comes with this formula. So very similar. The one thing you want to notice is that the up and down ones have an x squared, which we're used to, right? So x squared equals 4py. The left and right ones, the ones that go left and right, have y squared. So just something to take note of when you are trying different problems, right? The focus and the directrix all rely on this p value, right? We talked about p value in the previous video. That's the distance from your directrix to your vertex or from your vertex to the focus. They should be the same number. We're going to see how we can get that information from an equation, and then we'll attempt to graph based on that. Okay, so just we're going to use this information. So let's just get right into it. Identify the focus, directrix, and focal length, or some of the videos called it lattice rectum, of each parabola and sketch its graph. Always isolate the squared terms of the equation first. That's like a key thing. That's a little hint for you. Okay. We want it to look like this, one of these equations, so that we can actually associate the number to the right equation. We don't want to like set something equal that actually aren't equal. Okay. So for example, this first one, negative 1 over 12 times y squared equals x. That's really close to one of these. It's really close to the second one. But if you notice, there's nothing next to y squared. But in our equation, we have a negative 1 over 12. So we need to move and isolate y squared first before we can start figuring out what p is. Okay. So the one way to get rid of that negative 112 is to multiply both sides by negative 12. And what that does is it cancels out the negative 12 and the 1 over negative 12 on the left side. So we're left with a y squared equals negative 12x. So that looks a lot more like what we have in our general formula. If I line it up, y squared equals 4px, you can kind of see what 4p should be equal to, right? If I highlighted this 4p, that looks like it's in the same spot as negative 12. Right? So my goal right now is to figure out what p is, because once I can figure out what p is, I can figure out the focus, and I can figure out what my directrix is. So let's figure out how we can figure out the value of p. Since 4p is pretty much the same as negative 12, I'm going to set those equal. I'm going to say 4p equals to negative 12. And I solve for p using our algebra. So divide both sides by 4 to get rid of the 4, and you should get p equals negative 3. All right, so with our p, we can do a lot. We can figure out what our focus is. We can figure out our directrix. And we can even figure out our focal length, focal diameter length. Focal diameter, okay? So our focus, since we are talking about this set here, we're going to follow this set of rules to get our focus and our directrix. Okay. So our focus is going to be p0, which in this case is negative 3, 0. Directrix is going to be x equals a negative p, So x equals negative 3, which means that is x equals a positive 3. Focal diameter, we talked about this, right? It is going to be 4p. If you try to do 4p, you actually end up with a negative number. 4 times negative 3 is negative 12. But since we're talking about a length, we always want positive. So we always just take the positive version of whatever that is. That's why in our notes up here, it says we want to put absolute value of 4p, just to make sure it's always going to be a positive number. Okay. So your focal length here is 12, positive 12. So that's all the information we have that we need to graph our parabola. If, again, you need to go over how I did that with the focus, directrix, and focal length, go back to the previous video. Okay. I'm going to do this fairly quickly. So let's see. Focus is negative 3, 0. So negative 3, 0 here. Directrix at x equals 3. Vertex being right in the middle between those two things. Focal length goes along this focus. Okay. Again, parabola wrapping around the focus. That's what it'll do. So I know my diameter will go this way. Okay. Focal diameter of 12. That means I need to have an equal amount on both sides. That would be 6 up and 6 down. This gives us our 3 points to connect to get a parabola. Therefore, my final answer will look like that. Okay. A leftward facing parabola. All right, let's try number 2. So again, very similar to one of these, and you can probably see which one it is. It has an x squared, but I need to isolate that. I need to make that alone. Always isolate the squared term. Okay. So I'm going to subtract 10y to both sides to get negative x squared equals negative 10y. And I multiply both sides by a negative 1 to get rid of the negative attached to the x squared. That gives us x squared equals 10y. And that looks very similar to this general equation. X squared equals 4py. All right. Again, 4p is equal to 10. So I'm going to set that equal to each other. And get my p-value. We're going to end up at a fraction. That's okay. Sometimes we do. All good. So p is going to be 5 over, actually 10 over 4. Jumped the gun there. But when you simplify, that's going to be 5 over 2. With that value, we find focus, directrix, and focal diameter. So just reference these. Focus will be 0, 5 over 2. Directrix will be y equals negative 5 over 2. And our focal length, or focal diameter, is going to be 4 times 5 over 2. Battery's running out. But that will be 10, right? 20 over 2 gives us 10. Okay, let's try this out. We have fractions, so if you need to, change that to a decimal. 5 over 2 is the same as 2.5. So I'm going to count 2.5 spaces when I do these. Focus is at 0, 2.5. Directrix is at y equals negative 2.5. And the vertex right in the middle between these two things, my focal diameter is 10. So along the focus here, I'm going to go 5 spaces to the left, 5 spaces to the right. And with my 3 points, I can create my parabola. Let's start going a little quicker on this one. So number 3, 8x minus y squared equals 1. Isolate the y squared. Subtract 8x to both sides. Negative y squared equals negative 8x. Multiply both sides by a negative 1 to get rid of the negative. Y squared equals 8x. Matching that up to one of our equations to the top, 4p equals 8. P equals 2. Focus, based on our chart at the top, focus is 0, 2. Is that right? No, I think I messed up, right? Focus isn't 0, 2. Focus should be 2, 0, because we're using the y squared one, not the x squared one. So I messed up here. Focus is 0, 2. Directrix is x equals negative 2. Focal diameter, 4 times 2, which is 8. Focus is at 2, 0. Directrix, x equals negative 2. Vertex in between these two things with my focal diameter as 8. So finding my focus, going 4 spaces up and 4 spaces down. And there you go, that's my parabola. Working on this last one. This one's a little bit better. I have negative 1/9 x squared equals y. I need to isolate the x squared again. Therefore, I'm going to multiply both sides by a negative 9. Leaving us with x squared equals negative 9y. Matching that up to one of our general equations at the top should match up to the top equation, x squared equals 4py. Meaning 4p equals negative 9. P is equal to negative 9 over 4. As a decimal, you can put it in a decimal form if you want. That would be negative 2.25. Again, with our focus, or with our P, I can find my focus and directrix by following that chart. Since we are working with x squared, we are following the top row. Okay. So focus is 0, negative 2.25. Directrix is y equals a double negative, negative 2.5. So that will give me a positive 2.25. Focal diameter. Focal diameter will give me 4 times 2.25. Which will be 9, I believe. Yes, 9. Okay, focus 0, negative 2.25. So that would be 2 spaces and a quarter down. That's your F. Directrix y equals 2.25, so up here. Okay. With your vertex being between these 2 components. Okay. Finding my focus, I know I'm going to need to go a total of 9 distance, and that would mean I have to go 4.5 in both. I know these decimals are kind of irritating, but sometimes it's not always going to be a whole number. So let's split 9 up in half, so that's 4.5 on each side. 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a half. Total of 9 all the way across. And there you go, a downward facing parabola, which will be our last problem. So if there is any part that was confusing, which, there's a lot to each of these problems, go back, replay the video, and work on the textbook assignment that I have assigned on Canvas. I'll see you guys on Wednesday. Bye.